high availability, failover and clustering. With my ASA, I have multiple options for fault tolerance and also to achieve different performance requirements. So we have high availability by means of active standby failover or active failover, and I also have the ability to configure clustering. Not to mention that I can run redundant interfaces and I also support either channel. Let's talk for a moment about active standby failover. Active standby failover is when we have two ASAs that are operating in failover pair. We have ASA 1 here and ASA 2, and ASA 1 we are going to synchronize their configuration with the primary device, so device that is operating in active mode. So when we build our standby configuration, we are going to define one of these devices as being the primary and the other devices as the secondary. And then the primary should be active and the secondary will be standby. So what's going to happen is that the configuration that we have sitting on A or on ASA1 is going to be copied over to ASA2 through something called configuration replication. And then they are going to have an identical configuration sitting there. Now, none of the traffic is actually going to pass through that standby device unless there is a failure. So, if device 1, ASA1 were to fail, then the secondary device would transition to the active state and would now start forwarding traffic for the network. Again, the configuration matches, and so you have maintained all your NAT and access control and all of that on the secondary device as well. The one thing I will point out here is that some connections are going to be re-established. For example, if you are doing a AAA authentication, you're going to have to re-authenticate connection to the device once the switchover has taken place. So that's the active standby failover. Now some devices only support active standby failover on your lower end boxes, but some devices also support what's called active failover. And active failover is going to get you really the most bang for your buck. You're going to have two ASA devices, and those ASA devices will be operating and forwarding packets at the same time. So let me just briefly cover how that works. We will go into some of the details on later on, but let's just cover it briefly. We have ASA 1 and we have ASA 2, and these devices are going to operate in multiple context mode. Now remember, in multiple context mode, what we end up with is more than one virtual firewall operating at the same time. So let's say that we have CTX-A and we have that configured on ASA 1 and 2. And then let's say we have CTX-B, and CTX-B is operating on both ASA 1 and ASA 2. So we have traffic flow for CTX-A, and because we are configured for failover, we have got the failover replication happening. And the configuration from CTX-A on ASA1 is acting as the primary, and it copies its configuration to to ASA2, which is acting in this case as the secondary device, and it is in standby mode. Now it is this, at the same time we have got CTX-B on ASA2 that has a traffic flow through it. It's operating as a primary active device and is replicating its configuration over to CTX-B on ASA1, which is acting as a secondary standby device. So these would be two different independent firewall processing traffic differently. But what it does is it let us do a sort of a redundancy load balancing. So where you might see this, you might imagine that we have a router on either side of my physical ASA, and that router has, let's say, the router 1 and router 2 is on the other side of the router, and we might have a CTX-A on ASA1 that provides one route to get across, and that, let's say, we have ASA2 with CTX-B that provides a secondary route. So we can load balance traffic. We can send some traffic through CTX-A and ASA1 while we send other flows of traffic through ASA2 CTX-B. And if for some reason ASA1 were to fail and CTX-A over on ASA2 would then become primary active, or it would become a secondary active, and those traffic flows that were being sent up and across are now going to be sent through ASA2, and it will take all the traffic at this point, but again it offers us the high availability. So that's just a brief look at how active-active failover would function. Clustering. Now, our final high availability feature that we want to touch on here is clustering. So let's say we have couple of ASA devices, and really we could have like 8 to 16 ASAs in a cluster, and so I'm just going to draw out a couple. We will just use 4 ASAs, and these 4 ASAs are going to be connected to a switch. So let's just put a switch out here and then put another switch, and this cluster acts just as like a single ASA. Now these ASA are going to communicate with one another over what's called a CCL, a cluster control link. And so they will be able to have synchronized configuration and manage flows and so on and so forth. And the links between the switches and the ASA can operate as a multi-chassis ether channel. So this is just one big link, and we might configure this as a trunk and do the same thing on the other side. Do a trunk, and so it appears that the switch has a high bandwidth connection to a single ASA, and traffic flows through the ASA and these devices, whether it is ASA 1, 2, 3 or 4, they will be all deal with the flows of traffic. And how ownership is handled, they will redirect traffic to a proper ASA so that it can handle the stateful traffic inspection and so on. But again, clustering offers me the ability so that if one of the device in the cluster goes away, then the other device will still be there. So I have got some high availability, but I have also got some scalability here. So bigger links, a lot more connections per second handled, and again a very beneficial feature of the ASA 9.x code.